Hi. So in today's IBM Developer Talk, we're going to step through indicators of misconfiguration, indicators of compromise, indicators of attack, and provide the knowledge of what these are, how the cybersecurity industry is using them, and as a DevOps practitioner, whether you're a developer or a system owner, what these mean to you and how they might evolve your cybersecurity practice. So we really have three goals. Number one is to articulate what these terms are: IOMs, IOCs, IOAs. Know the difference between them because we're probably going to hear them not just in the cybersecurity community, but also in news headlines and articles. And the theory of this talk is to provide a baseline understanding. For example, are indicators of compromise the same thing as antivirus signatures? What do these really mean as a practitioner? And then as a practitioner, arm you with a couple tools that are tangible and real that might help improve your overall cybersecurity posture for misconfiguration analysis, for indicators of attack. And through that, to introduce myself, my name is Sean Wells, and I'm the Vice President of Solution Architecture at CrowdStrike. We're a cybersecurity firm known for our presence on endpoints and stopping breaches from laptops to servers. And in today's conversation, we're going to focus on servers in the cloud, specifically on OpenShift and what you might be able to do. So, from a industry presence, I was a co-author of the OpenShift Security Guide, which is a book about OpenShift security. The OpenStack Security Guide, also a book about security. And I'm the co-maintainer and co-founder of a project called Compliance as Code. And in that, we create automation technologies to evaluate configuration and known vulnerability analysis of system components. So I speak to you, yes, as a crowd striker, but also as an industry participant, where this isn't meant to be a sales pitch. It's not meant to be a product demo, really to try and help you understand the terms that are evolving in industry. So in industry, really one of the first examples that I'm aware of is from 2003 when there was a Senate hearing that said, why is the government getting hacked all the time? How are these nation states coming in? And there was this perception that it was these advanced lurkers on the dark web with 0 days and super advanced tools. In reality, it was misconfigurations. Common misconfigurations accounted for approximately 80% of the breaches in the US government. So things like not turning on encryption or having telnet running. So wouldn't it be nice if we could just automate the evaluation of these misconfigurations? And that began the saga or the journey towards indicators of misconfigurations, or you might hear them called IOMs. And one of the most, predominant ones, and really the chances are you've seen something like this regarding passwords. Do you have uppercase, lowercase, alphanumeric? Is the system timing you out after a period of inactivity? And these classic technical controls are generally set by a CTO or a CISO, in some cases like an information system security manager. But regardless, they're technical settings about some kind of tunable on the system, like a password length. But combined with these technical controls are organizational ones. So, for example, line, what is it, 4 or 5 here, establish conditions for group membership. So, think of it like maybe for the developer network, you need to be a developer, not somebody in marketing or finance. So that's more of an organization control. Together, these technical controls with these organizational were put into a baseline. One of the more famous ones in the government space was the Department of Defense STIG, or the Security Technical Implementation Guide. As we move on to other aspects, we'd have things like HIPAA. So that would be for healthcare. You'll hear Center for Internet Security or even PCI DSS. But the whole idea is that some body established a collection of technical controls, like password length, and wouldn't it be nice if we could evaluate them? So the government or these other industry bodies are creating control catalogs. So, wouldn't it be nice if we could create a response catalog that could be dynamically generated? So, if I, as a system owner, say, you know what, I have to adhere to PCI DSS because I'm processing credit cards, and my stack composes of my SQL database, Nginx web server, and some Linux operating systems. Wouldn't it be wonderful if I could say, you know what? Here's how I enforce encryption on all of these components. If I'm using usernames, like probably at the operating system level, here's how I enforce password complexity. So, our goal is to create reusable parts with technical implementation details for popular system components. And this begins a story of two industry movements. The first, which you may or may not have heard of, is called OpenControl. And at its core, it's a YAML based format that allows us to express organizational responses like you have to do backups. Sure, here's how I do them. You have to have policies for group membership. Sure. In order to be in the developer network, you have to be a developer, not in finance. So it allows us to bake in technical responses to organizational controls. Along with that is something called the Compliance as Code project. And over about 10 years now, the community has grown to roughly 200 individuals from academia to industry participants, Lockheed, Booz, Accenture, Red Hat, CrowdStrike, and government as well. So people like NIST, who are setting formal standards, as well as the Department of Defense, are all coming together to say, you know what, we do have to have complex passwords. We do have to enforce encryption. What's the best way to do that for Nginx or for Linux or for pick your favorite database server? So we want to dive into this project, the Compliance as Code, show what it is and maybe how you can use it. So through that lens, there. So as we pause and flip over to the actual console, the Compliance as Code project is available on GitHub. And what I wanted to do was show a couple checks. So I mentioned there's a YAML based format. So right now we have a configuration check that's apparently applicable to Red Hat Enterprise Linux, Oracle Linux, Fedora, SUSE, and it basically says ensure GPG check is enabled, which is telling the operating system make sure all software that's installed has a cryptographic signature from some known publisher. And if I do this, there's a whole bunch of references. So if this configuration setting is enforced, there's attestation back to ISO 27K, to NIST 853, the DoD STIGs. It looks like controlled unclassified, to HIPAA, and so PCI DSS. So now what we're able to do is enumerate technical controls like turning on encryption, mapping it to configuration baselines such as PCI DSS. And as we go in, there's different ways to attest this. And it's called Security Content Automation Protocol. Let me make it just a little bit bigger. So right now, the idea is not to turn this into a specification talk. The takeaway is that there's an XML format that allows us to enumerate a file. So in this case, the path is etc yum repos d, a pattern match. So I'm looking for GPG check equals something. And then if it's there, I want to return something. So in this case, I'm ensuring that GPG check equals 0, that it's never disabled. And if it is, what we end up doing is automatically baking in remediations. So if you're using something like Ansible, now I can go in, I can get all my yum repos, and I can ensure GPG check equals true. If you're not using Ansible, well, one of the common scripting languages available on every system is Bash, Ubuntu, SUSE, CentOS, RHEL. So now I can have a technical control. I can have automated evaluation, which is that XML format, and I can have automated remediation in languages like Chef, Bash, or Ansible. So it allows us now to take these technical baselines and actually make them into a standard. We go ahead and publish that standard in something called the NIST National Checklist Program. So if I were to go to NIST NCP, NIST NCP, it's the first available link. So the NIST National Checklist Program has baselines in these standards for Windows, for Office 365, for Cisco iOS routers, Chrome, and IBM WebSphere, many different things. So now what we're able to do is take a known standard expressed in a component agnostic way, this XML thing called SCAP, and evaluate for misconfigurations for Chrome, for Windows, for web servers, for Linux, and so forth. And that journey is ongoing, but that's what we're largely referring to when we say indicators of misconfiguration. We're trying to get at the different nerd knobs in the system components. When we combine all this together, it allows us to get that classic Christmas tree, the red light, green light, pass or fail. Am I misconfigured? And as I showed, it has those policy mappings. So on the screen are the NIST 853 mappings, which link to PCI DSS, to controlled unclassified, to HIPAA. So it allows us to enumerate them at a per control level. And a lot of these technical specifications don't really do you much good unless they're natively exposed in the platform. So, to accomplish this, we began developing something called the OpenShift compliance operator. Underneath the covers, it uses that SCAP, that XML language, the remediation capabilities, the compliance as code project. However, it exposes it really in a pleasant UI and in a Kubernetes native way through an operator. So if you log into your OpenShift consoles, you can actually install the compliance operator. And what it allows you to do is from the interface, you can select a couple pre-canned profiles. So on the screenshot, I'm showing some of the profiles that ship to evaluate the OpenShift cluster itself. Is OpenShift configured to Australian Essential 8, which is one of the baselines for the Australia New Zealand market? Is it configured to the Center for Internet Security, or CIS? So it should be explicitly noted that the compliance operator can take and ingest third-party content. So since this is a developer conference, imagine creating custom configuration checks for your stack. When you compose presumably a pod or really just a workload, you most likely have a database server, you most likely have a web front end. So you can actually go to the NIST National Checklist Program and pull down the checklist for Nginx or for JBoss or pick your favorite. So the other aspect is we can start writing content for your specific application. So now when we want to look for indicators of misconfiguration, it's not just about the infrastructure, meaning Linux and web servers. We can actually tailor and create content specific to your app. So maybe there's a configuration setting you need, maybe it's security, maybe it's performance related. Anything that can be attested through an automated means like an API or through checking a configuration file, we can embed into the OpenShift compliance operator. So think through it. And as we go on, you get your pass or fail. All of this is enumerated. So now we can start creating logic. Like, you know what? If the Linux base image is not configured, maybe to enable certain encryption standards, don't allow the workload to be deployed. If the OpenShift cluster is not configured in accordance with your PCI DSS policy, maybe evict it, put it in a maintenance node and evict the node from your cluster until it's remediated. So these indicators of misconfiguration, to take a kind of a pause here, really allow us to follow a standard called SCAP, Security Content Automation Protocol. There's a publicly available checklist of these baselines provided by NIST, which is the standards agency of the government. And really, this is a chance to evaluate if this might be a good thing for you. Again, 80% since the early 2000s, 80% of attacks are using misconfigurations. So this is a way to address an enormous amount of risk in an automated way following OpenShift native technologies like the Kubernetes operator, the compliance operator. So that leads us into kind of this next level of the conversation. And really for the last few years, the security industry's kind of become enamored with indicators of compromise as a way to detect targeted intrusions. And arguably, adversaries are flying right past traditional means. So there are now numerous vendors who are building products which scan and search for indicators of compromise. They may enable sharing or blocking of indicators of compromise. And the argument is that these old style signature based solutions, which is a nasty way of saying antivirus, are failing to stop these more advanced attacks. So the argument goes you need something new, something brand new to detect these previously unknown capabilities. And that really sounds great until we start decomposing what an indicator of compromise really is. So it could be an IP address. Perhaps you're getting DDoSed or there's a botnet. It could be a domain name or URL, like a exfiltration to a dirty domain. It could be a file hash or a file name, such as a malware sample. Or it could be Windows registry keys or a byte sequence and so on. So when you ask yourself, what is it, or rather, what is a signature that an antivirus solution might look for? You're going to say some of the same things. It's a hash, it's a file, it's a registry setting, and it may start to look familiar. So, arguably, we can start saying indicators of compromise are very little than rebranded signatures, and they still rely on historical knowledge of what's going on in order to be able to detect things. And if I take a breath, it feels a little odd to say that, as CrowdStrike has next gen antivirus. And I don't mean to be terribly disparaging. They are needed, right? If we want to know if a malware sample is executed on our workloads or our endpoints. But again, they're looking in hindsight. So if an adversary engages in malware free intrusions where they've somehow acquired legitimate access through other means like credentials, stolen credentials, phishing, and then they engage probably in lateral movement, there's almost no indicators of compromise for you to scan or use to identify such intrusions. So indicators of compromise are kind of stuck in this weird limbo in the cybersecurity world right now. They're useful, but they're not necessarily forward looking. So we can think of these indicators of compromise, at least as they're described in the forensics world, as evidence that indicates the security of something on your network has been breached. So investigators will usually gather this data after an incident or after a suspicious activity, perhaps on a scheduled basis, and that's it. You capture the file hash, you capture the Windows registry setting. So that moves us on to something called indicators of attack. So these are focused on detecting the intent of what an attacker is trying to accomplish, regardless of whether malware was used. And it's just like antivirus signatures, a indicator of compromise-based detection approach really can't detect things like 0 days. So as a result, industries moving towards indicators of attack. So these identify patterns of behavior or patterns of system activity that are malicious without relying on signatures or machine learning. And in industry, you're going to start hearing about event stream processing to look at the behavior to determine if it's malicious or not. So think about if we're stealing from a bank, chances are the bad guys go into the bank and case it. They walk around, they look for security cameras, no big deal, then they leave. Somebody walking in and out of a bank, generally not a big deal. But let's say the exterior security cameras catch them driving around the building during the morning, during the evening, kind of random times. Well, now it's a little bit more suspicious. And then let's say a business down the street gets robbed or something happens and the police come, chances are they're trying to measure response times of law enforcement. So again, either any of these activities on their own aren't so suspicious, when we create this pattern of behavior, we might want to increase our threat level. We might want to say, you know what? We got cased, then they drove by. Now there's police response down the street. Something's bad is happening. So, event stream processing is the technique used in industry to combine artificial intelligence and kind of this expertise to both identify and block malicious adversaries. So, in this particular example, bringing it back to the computer world and the cyber world, we see that we have a process looking for all the different files on a system. It's deleting the backups and then ultimately calling an encryption routine. So, you may recognize this pattern of behavior as ransomware. Somebody probably clicked something, they ran something. Now they're being ransomed probably for Bitcoin. So, what we end up doing is indicators of attack can take these sequence of events, process them, and automatically detect and block it. So, this kind of logic will block almost any variant of ransomware because they have to perform all these activities. So, if we explore kind of the tradecraft here, let's say an adversary has malware that's memory resident. They're using a tool like PowerShell with some command line arguments, and then they clean up after themselves. If we compare the historical state of industry to, say, antivirus, well, the malware was never written to a disk. Most antivirus solutions are set for on demand scanning. There's probably nothing your antivirus can do here. If we move into antivirus 2.0, or you'll hear them called next gen antivirus, well, these solutions are using machine learning generally to determine if something is good or bad. However, since the attack uses PowerShell, which is a legitimate Windows system tool, it's not going to be identified as malicious. So next gen AV, probably not so useful. We then get to indicators of compromise scanning. And again, since the adversaries never write anything to disk, it's memory resident, there's no indicator of compromise. There's nothing written to disk. There's logs that are cleaned up, most likely through automation and programmatically. So, what indicators are going to be there? Really, not too many. So, by focusing then on the techniques, the tactics, the procedures of targeted attackers, industry is moving towards the ability to determine who the adversary is, what they're trying to access, and why. So by the time you detect indicators of compromise, most likely you've already been breached. And that's why there's so much talk and there's so much press about vendors, including CrowdStrike, making noise about indicators of attack. So, indicators of attack for cloud, for DevOps, for containers. So, really, what we want to do is actually show you these in the next couple of minutes to try and make it a little bit real. The first is malicious modification of a container entry point. So, running a container has an entry point, most likely to start your service. So, if I flip over, what we're able to do now is this is the Falcon platform. So in this particular case, I ran a demo. Today's the 23rd. I ran my demo scripts last night to make sure the data was populated. But I have an example, Kubernetes pod. And in this case, there was a detection for a high severity finding that says a bash reverse shell. And here's the code. So it looks like it was a base encoded exec string. So they're probably exfiltrating data, something like that. So if we start, this is kind of what we mean by the event stream. At CrowdStrike land, we call it the threat graph. But essentially, there is a container ran on this host, this IP, this container ID. It calls an entry point script. So really, there's nothing here, right? It's just a normal process. Big deal. That then called, let me rephrase, the entry point then called a shell script that actually enables a web console. Okay, so maybe that's a little weird. That web console runs a command and control, and then all of a sudden, somebody's connecting into the bash reverse shell. So these first few activities, an entry point, running a service script, probably not a big deal. But when we combine them all together and we start seeing traffic, specifically the reverse shell, we know an adversary has breached your system. So that's kind of what I mean, where we are able to daisy chain these events at a system level, whether it's inside a container image, a pod, whether it's the OpenShift infrastructure itself, and actually create notification of a breach. So another example then is we want to talk maybe about public cloud. So in this case, I created an Amazon instance, meaning an Amazon account that has EC2 instances. And the security group was modified to allow data coming in from the public internet. So hopefully, none of your databases are exposed to the internet. So if somebody changes your ingress policy to allow incoming traffic to your database, it's probably a red flag. So I can get about it. I get some actual raw user data, who's going in, what they're doing. You can see there's a demo generator, but as well as human accounts. And as we go in here, it looks like on the 21st, so just a couple days ago, when I executed the demo, somebody logged in and did a describe EC2 security groups, and then just a little bit later, actually looking at the timestamp several hours later, they did it again at roughly 11:04 and 27 seconds, and then just a second later, they're calling authorized security group ingress, which is allowing external data traffic. And then they described the group again, presumably to see if it worked. And these sequence of events, describing a security group, not a big deal. Describing a group and then half a second later doing an ingress, chances are it's an automated attack. So we now have these cloud native indicators of attacks, whether they're containers, whether it's for the cloud fabric. You'll start to hear two different terms. When it's about the cloud fabric, we'll often be talking about cloud security posture management indicators of attack. Basically, it's your management plane, your EC2 console, your OpenShift console. When it's the container workload, like an entry point kicked off a malicious script, you'll start hearing language about cloud workload protection, or CWP. So that's really kind of an attempt to enumerate the difference. Now, as we kind of close this in, we really want to evaluate, did we meet the goals and the outcomes of this session? So number one, how has industry evolved from misconfiguration to indicators of attack? So we started back in the early 2000s recognizing 80% of breaches were misconfiguration. We built baselines such as HIPAA, Center for Internet Security, the DoD STIG. And to automate those baselines, we have the Compliance as Code project, which creates standardized ways using this thing called SCAP for system components like Windows, Linux, Chrome, Cisco iOS, Nginx, and these are published through the NIST National Checklist Program. As we move on and have the indicators of compromise, in reality, they're kind of the same as next-gen antivirus. They have file signatures, they're blocking registry settings. They're doing it in a bit more intelligent way. So instead of having a file that's getting downloaded, your signatures file, usually there's some kind of on-sensor machine learning to detect the activities of these files and settings. So it's a bit smarter next-gen AV. And then as we move on towards indicators of attack, it's this event stream capability to determine what's going on, how's it happening, the sequence of events behind the actual breach. And that's kind of how we differ between indicators of compromise, static signatures, and indicators of attack, which are much more real-time based. So as a team member, some of the practical tools that we hope you leave with are the Compliance as Code project. Number two, the OpenShift Compliance Operator, which can not just scan your system components, but also write your own content for your own application. And then if you're interested in learning a bit deeper on these indicators of compromise, on how the OpenShift Compliance Operator works, or indicators of attack event streaming, we're going to leave a couple links in the slide deck and the notes for you to learn more about. So thank you for your time, and I hope you enjoyed today's IBM Developer Talk.